Can you hear me? All right. Good afternoon, everyone. My name is Ahmed Laraki. I'm a product manager for Google Gears. Thanks for making it with us all the way to the last session of the day. And we saved some of the most exciting stuff for the end of the day. So this session is called Nuts, Bolts, and Gears. And it's about the usage of toolkits with Google Gears. Let me move this. All right. Am I on the wrong? Oh, no worries about that. So probably a lot of you have already attended some Google Gears sessions earlier today. As you know, Google Gears is a browser extension that enables web applications to work offline. I won't go through the details here, but one of the main points here is that we are trying to extend web browsers in an incremental way so that developers like you can start creating interesting applications and make them independent of the network, if you will. And part of that with Google Gears is that we created an API that is very low level. We created the basic core primitives that we think are necessary to enable applications to work while disconnected. But then, in terms of for actual developers who want to build more complex applications, the layering of functionality on top of that becomes very important. And so that's why we have a session about using toolkits, various toolkits on top of Google Gears. I'll introduce Brad Neuberg from the Dojo team. I'm sure you've heard a lot about the work that Dojo has done with AJAX toolkit. It's probably the most popular AJAX toolkit out there. And they have done a lot of very interesting work on offline. And after that, he'll be followed by Dan Morrill, who works on the Google, or we call it GWT. Is that an okay way to call it? All right. Who works on GWT, which also facilitates the creation of AJAX applications. And we'll talk about some of the work that him and his team have been doing. So with that, I'll pass it on to Brad.
Oh, it was working. No? Murphy's in the house.
Oh, that's lovely.
That's the Haight-Ashbury version.
All right. Are you finished with this one?
I think that Dan's going to be using that. Yeah, let me just, it was working. Let me undo it and then. How's everyone doing? It's been a long day, huh? How many people have drunk coffee today? Not that many. There you go.
Let's try this.
Do the old one.
Yep.
Okay. We are experiencing technical difficulties. Cool, there we go.
So we'll probably have to do back and forth.
Okay. That was a near miss there. Hi, my name is Brad Neuberg, and I work with SitePin and the Dojo project. And today I'm going to be talking about Dojo Offline meets Google Gears. And of course, the keyboard's not working. There. Is Murphy in here? All right, we'll do it the old-fashioned way. Is that fine? Can you read that? Play mode won't work for some reason. There we go, now it works. So what is Dojo Offline? Many of you may not be familiar with Dojo and Dojo Offline. So Dojo Offline is part of the Dojo Toolkit. Dojo Toolkit's been around for several years, and our goal with Dojo is to be a standard library for you to bundle into your JavaScript and AJAX applications. And Dojo Offline is open source, and it has a really focused goal. And that is to help you create offline web applications that run in the web browser and that work across current web browsers. So Dojo Offline is meant to make the web work offline. So one of our big goals in Dojo Offline is to be a realistic solution ready to deploy today. Something that we can start using today without new browsers and without having to have an entirely new browser. And our mantra is to be small, to be easy, and to be open. And actually, about a month ago, we released a beta. And Dojo Offline consists of two pieces. So we have a JavaScript library that I'll be touching on, and then we have a small runtime, which is a downloadable component similar to Google Gears. And that JavaScript library does a lot of the hard work for you around offline applications. So how many folks here went to some of the Google Gears presentations throughout the day? Fireside chat. So a common question was, how do I do syncing? Some people ask, what about user interface? Just knowing when the network has appeared and disappeared and just having local storage, that's the beginning. That's the starting line of offline applications. So Dojo Offline has this JavaScript library that helps take your hand and step you through all the steps that is required to go into this offline world. And I'll be going through these on a high level today. And the second part is a small runtime that we created. It was written in cross-platform C, and it was about 300K for Windows and for the Mac across the contemporary web browsers. And we finished a beta of that about a month ago, but we've decided to get rid of our runtime and bring Google Gears underneath. So we're keeping our JavaScript library, and we're bringing Google Gears underneath. And we had something similar to Google Gears. And when Google and Dojo started talking, the natural question is, why Dojo Offline plus Gears? Well, one of the interesting things was that we were going in a similar direction. We believe in the open web. We believe in offline web applications. And we had our runtime, and Google has their runtime, and all of us are moving in the same direction. So we're like, we don't need a VHS versus beta battle. And that doesn't help developers. It doesn't help the web. So we're like, let's not do that. It's our responsibility to get into one of those. So we said, OK, how can we put these things together? So Dojo Offline, with that JavaScript library, does a lot of that hard work, like I've said. And when we put that with the Google Gears, we get the reach of Google. We get the reliability of the Google engineering team. Google Gears is really strong. So when you put these together, you can build some really cool stuff. So I'll be running through the APIs and giving you some demos today. So I want to give you a quick demo. So much of what you'll see today is we've finished a prototype of porting Dojo Offline on top of Google Gears. And in about 2 weeks, we will release the full integration as part of the Dojo project. And one of our example applications is called Moxie. And this is actually bundled with Dojo Offline. It's a web-based word processor, meant to be a real application that really exercises the offline web. And as I'll be showing you, it uses a lot of the Dojo Offline framework. Over here in the corner is a user interface widget that tells the user when you're on or offline, helps provide syncing, and so on. And right here are some documents that have been synced from the server. Right here is actually the Pablo Picasso page from Wikipedia. And this is sort of a simple web-based word processor. So we can say, hello, Google Dev Day, and we can save. And in the background, the Dojo Offline framework is also checking to see if the network is there or not. And in this example, the server is running on my laptop. So to simulate the network disappearing, I'm going to kill the server. And then in the background, Dojo Offline, as part of the framework, every 15 seconds is looking to see if your web application is available. So this is another one of the things it does for you. Many people think that just seeing if the network is there is enough. But what's actually more important is my web application available? And boom, you saw that it shifted offline automatically. And now you can work offline. When the network reappears, the framework will automatically resync with the server, upload data that was changed, and make things available online. And again, it's at about a 15-second interval so that we don't sort of pound the server or overwhelm the client. It's a good trade-off. And as you'll see, most of this application is using the framework. So the framework's doing a lot of this hard stuff for you. So let's jump into that. So one of the first things that Dojo Offline does for you is it helps you with user interface. So creating a good offline user interface is not easy. So with Dojo Offline, what we've done is we've created a default user interface that you can plug into your page. We've done usability testing around that. We've made it so that you can very easily drop that into your existing application. And let me show you what that looks like. In order to get this in your HTML, can you read that? Can people in the back read that? You just add a div to your HTML with a magic ID, .-widget. And that will get automatically filled in with that little offline widget that you saw. And you also, in your JavaScript, you simply set the name of your application. So this says dojo.off.ui.appName. We set it to Moxie. That's the name of this example app. And then, when the page loads, that offline widget magically appears. And it handles lots of this UI stuff. Like I said, network status. Tells you when you're on or offline. It provides syncing messages, canceling syncing, successes. It also provides a standardized set of instructions that when a user clicks on that Learn How link, takes them to a page that directs them on how to download Google Gears and start using this application offline. These are the kinds of fit and finish things that are hard to get right, and we provide them right out of the box. And one thing I want to mention, well, I don't have time to go into it, but that look and feel, it's deeply configurable. You can just take what's there, and then there's all sorts of levels of playing with that to make it really work with your particular branding and user interface. So I already mentioned network status. In the background, every 15 seconds, we check for web application availability. And this happens out of the box with Dojo Offline. You don't have to configure this. And something that's really cool is we've also hooked this into that default user interface. So that little widget updates itself, tells you when you're online, and then when you're offline, does the same thing. Again, less work for you to get these out the door. And of course, we provide hooks that you can tie into to override this. If you set dojo.off.onOnline to a function, that will be called when we go online. Of course, on offline. So you could take over a little bit, let the default UI widget help you, and perhaps enable and disable parts of your user interface that aren't available offline. So whenever you start creating a sort of offline, let's see if I can get this a little bigger so it's a little more readable for y'all. Whenever you start creating an offline application, you have the problem of how do I make my resources available when I'm away from the network? My JavaScript, my HTML, my CSS. Okay? And with Dojo Offline, all you have to do is call one method, dojo.off.files.cache. And you pass in an array of the things you want to have be available offline. So really simple. So right here are some example resources that are used in the Moxie example. So HTML and JavaScript and an image. So how about offline data? We've got user interface. We've got our files. What about data? Well, we have a new library called dojo.sql. And this causes every site to get a relational data store. This is built above the Google Gears very cool database stuff. Of course, we can execute SQL, the full range. And again, we've really focused on productivity. So here we are. To execute some SQL, you just call, say, dojo.sql, and you pass your SQL in. And what's handed back is a JavaScript object. There we go. And that is just an array, where each entry of the array is the row that matched. And then we automatically take the column name and just make that a JavaScript property. So with this, if we had a customer table with a first name and a last name, and we did a query, we just get back a JavaScript object. We can just iterate over that like an array and call each of those values. So really straightforward to use. Here's an example where we're using some more advanced SQL. We're doing a create table, perhaps the first time an app has been used offline, just to show you can get more advanced. And then when you need to give parameters, you just put question marks. So here we are inserting into SQL. We insert into a customer table a first name and a last name. And all you do is you put question marks for the things that you want to fill in, kind of like printf. And then afterwards, you just put a variable number of arguments, again like printf. A little similar to JDBC, if you're familiar with that. So a really common use case, when we were working on Dojo Offline, we've been kind of cranking Dojo Offline for a while, and something that's really important is we went out and we asked different kinds of people how they're going to use offline. And a certain class of people were like, wow, offline, that's really cool. but I can't use it. What about a stolen laptop? So how many people here have heard in the news about like stolen laptops last couple of years that have government information on them or university records? Yeah, it seems to happen every couple of months. So it's a very important use case. If we're downloading local data onto the client and that gets stolen, that means an entire swath of industries can't adopt this. So what we've done, so actually here's the use case, right? So let's say I want to insert a social security number in, and if I just insert it into that local data store, someone with a stolen laptop could read off all those social security numbers. So that's an issue. So what we've done is we've introduced a new keyword, encrypt, that you can put around any parameter individually or a list of them, and then you provide them, and then you give a passphrase. And the use case here is every time a user uses this particular app that needs to be secured, they authenticate, type the passphrase in, and under the covers, we're going to use that passphrase to do encryption of the thing that you want. So right there, we're saying encrypt just the social security column. Decryption is just as straightforward. We have a decrypt keyword that you can put around the social security column, so when it comes back, which you see down there, it becomes asynchronous if you use encryption, which I'll explain why. You can deal with it like a normal JavaScript object. So what's going on here? So what we have actually done is we've taken a JavaScript encryption library. It's actually the DES library, which was created by a guy named Chris Vaness. He did really good work on it. And we've actually done that in JavaScript. And traditionally, that's not a realistic thing to do. Because actually, JavaScript encryption is not that bad. But the problem is it's computationally intensive. So in the past, it would lock the browser up. But you can get quite a lot done. So what we've done is we've actually used the Google Gears worker threads. So we don't block the UI. And we can encrypt and decrypt about 80K a second. And of course, this is experimental, obviously. And the other thing we've done is we've hooked it into that Dojo.sql layer. So these things become much easier for developers needing this kind of functionality. So let me give you a quick demo. This is a customer table with a last name, a first name, John Doe's, and then a social security number. Okay. And then I've put a big chunk of text instead of one of the social security numbers, just to show you that we can crunch a little bit more. Does that make sense? What that is? And we want to encrypt the social security column. So if I enter a passphrase, boom, very fast, didn't lock up the UI, it now becomes gibberish just on that column. If I don't have the passphrase, I still get gibberish. But if I have the passphrase, boom, magically, we get back our results. So helping you solve that problem. Sometimes you don't want to have to drop down into SQL. So who here likes SQL? It's okay to admit I like SQL. And who here also dislikes SQL for certain things? Yeah. So it's appropriate sometimes, not appropriate other times. Sometimes all you want to do is you want to build a quick prototype using this stuff. You haven't gotten sign-off from your manager yet. So you want to roll something cool really fast to show your manager to get sign-off to do the bigger offline implementation, right? So we have something called Dojo storage, which is much easier than SQL. It's just a hash table. And it's pretty much two methods, a put and a get. It's a big bucket. And it's persistent. And under the covers, we're persisting that into the Gears SQL storage. I'll show you a quick demo of that. So this is a testing page for Dojo storage that allows us to play with the Dojo storage persistent functionality. And we can put a key and a value in, just like a hash table. Is everyone here familiar with hash tables? Yeah? Okay. It's basically just a bucket you can put stuff into with a key. So if we put a key and then the word hello world and save, it's saved. Really straightforward. And just to show we can do more heavy lifting, I've got some links here that will auto-save some larger and more robust things into storage. So like that just saved an example book, an entire book into Dojo storage. And it's actually Faust by Goethe, taken from Project Gutenberg. I'm really proud that I think Dojo is the only project that in its Subversion repository has Faust, and it's in the repository. And it's kind of geeky, kind of literary geeky. And then we can also save XML. And the key was test XML, and this is an Atom feed taken from my Blogger blog. So you can get quite far using simple Dojo storage. And one thing to mention is that what's really cool is that under the covers, this is just a SQL table. So you could read that data as you become more sophisticated and migrate it at a later time, as you iterate your application. Syncing. I think someone was mentioning that you can spend forever on syncing. Syncing is one of those things that if you're not careful, it's like a rabbit hole. You can kind of fall down the rabbit hole and you wake up like 2 years later and you're like, how can I do syncing for my application? If you make the wrong choices with syncing, you're going to take a long time and you may not be able to ship your application. So syncing is really important. When we first started building Dojo offline, we thought, oh, we'll do syncing later. And what kept coming up is if we were intellectually honest with ourselves, syncing was one of the things that's really hard. It's like those frameworks that say, oh, we'll leave authentication to the programmer when they don't really kind of help you. So unfortunately, I don't have enough time to go deep into syncing. I kind of want to touch on what we provide with Dojo offline. So we have a library called Dojo Sync. And that's a framework that provides intelligent defaults. And it gives you some very discrete hooks that you hook your JavaScript into. It tells you when to upload data that the user created while offline. It tells you when to download data that you can then store into storage. And what's really cool is it integrates really well with that default offline UI widget. So again, you plug that default UI in. On page load, it will auto-magically sync when the network appears, and it will call your hooks. Download new data, upload new data. And again, something that's really important is that manual syncing is not required. Again, the first iteration of Dojo Offline had this really big UI widget, with all these settings. And as developers, we were too close to the problem. We thought that users cared about syncing. And it turned out they just wanted it to work, but they wanted some minimal feedback, just like you need the browser throbber button to spin when you're on the network. The network needs to be acknowledged, but you don't want to throw it in the user's face. So syncing happens automatically when the network appears, because you never know when you're going to lose the network. And it will download a subset of data. The cool thing is, when you're offline, the syncing model that we have is a command log. So I add a customer while offline. I delete a customer while offline. Dojo Sync gives you a command log that you can store user actions on. And that gets persisted. And then when we go back online, we just replay that command log. Add that customer, delete that customer. And your callback gets called to do what it would normally do online. Call some existing service and so on. So it's very lightweight. We had an initial Dojo Sync that had a wire protocol and required complicated server support, but it just wasn't realistic. This is lightweight and realistic. So that's Dojo Offline. We give you a default user interface. We give you a way to cache your files, a way to cache your data, either using SQL with this cool encrypt and decrypt, or Dojo storage for a simpler hash table. And we give you syncing. And of course, our runtime is now powered by Google Gears. Our philosophy throughout the framework is that everything should be changeable, but we should have intelligent defaults. Make easy things auto-magic, make hard things possible. And of course, deep customization. Simple, easy, open. The status of this porting work is that we had a beta that we released a month ago, like I said, and that had the old runtime. That was released at the beginning of April. We're currently in the middle of the Dojo Offline Gears port. The things I was showing you today is a prototype of that integration. And we have about 2 more weeks until we can push that out the door. And I wanted to acknowledge special thanks to Google for financial help with this porting effort, and for SitePin, which is putting resources towards this as well. So, and here's the Dojo website, if you want to go to that. And thank you. So I wanted to introduce Dan Morrill from the GWT project, who's going to be talking about a sister AJAX toolkit and how it's integrating with Google Gears.
Great, thanks. Thanks, Brad. That was actually an excellent presentation, and I personally am very excited to see the interest and activity around Gears. So for our part with GWT, we've been working on a library of our own, and we, in this process have encountered a lot of the same types of, obstacles and speed bumps that Dojo guys did. And so I sort of have two goals for what I'd like to talk about today. The first is to show off the library that we have working now. And in particular, I want to do that by showing a demo application that we've put together. The second thing I want to do is actually go into a little bit of detail to show you specifically how an application could be built with Gears. And so I don't want to assume necessarily that anybody here knows what GWT is. And so the quick one-sentence summary is just that it's a toolkit, including a Java to JavaScript compiler and related support libraries that let you build AJAX applications using the Java programming language. Gears, of course, is our new effort that allows you to build offline capabilities into AJAX applications. And so together, we think that there's a lot of potential here to help Java developers continue to leverage their favorite tools to build AJAX applications. Yeah, there, you've seen my slides. Really what I want to do, I think, is if I can get it to respond. Whoa. Sometimes you just have to threaten it a little. So this, as you might be familiar, is Eclipse. I'll try and explain what I'm doing over here, since that might be a little small to see. But this is a standard Eclipse. This is a GWT project that I've got here. And if you're at all familiar with Java development, you'll recognize this as one of the premier IDEs. And so what I'll do is actually fire this guy up. So we have this application that we put together called GWT Note. It's kind of funny, when I started developing this particular sample application, I did not realize that it ends up looking a lot like Moxie, which you'll see in just a moment. What happened there is I forgot to start my web server. And so right now, this is our GWT hosted mode, which is our standard hosted mode environment. As you can see, it's loaded up the application, and it also is a rich text editor, although it does function a little bit differently than Moxie does. So I'll just type some text in here. And what this is actually doing is it is just storing some text in here in an editor. And what it's actually doing is storing text automatically. So as you type, it's actually saving it to, in this case, the server, because the version of the application that you're seeing right here does not actually have a, oh, hey, what's this? Let's see, what is this? Rich text widget, line 225, huh? Well, this is a loop. And oh, right, yeah. So what I'm doing in this loop is I'm comparing two arrays and iterating over them both. But I neglected to check whether they are actually the same length. But because it's just an equality check anyway, I'm just checking if these two lists have the same data, I can do that. And so I'll just add the little, thing there, and now my application works. And so what I just did was updated my application in real time and saved it to the disk, and the GWT hosted mode browser picked up the change I made and let me proceed with it. In this environment, you can also set breakpoints and everything. I won't really go into a lot of detail in this, but I intentionally left that bug in there so that I could have a little segue into the source code here, which I want to cover real quickly. So this particular method that had the bug in it is the method that sets the contents of this guy here. And what's going on here is the browser has an in-memory state, so it's stored a list of notes that it's aware of. And it exchanges its state with the server, and the server negotiates conflicts between two browsers. So speaking of two browsers, I've got a little instance of Firefox over here. And I'll come over here and copy the URL. As you can see, as soon as it loads, it immediately has the contents that I typed into the other browser. And this is all live. So if I come over here and say, this is interesting. What's going on here is that this is WebKit. Since I'm running on OS X, this is Safari. And the rich text representation of the same string is different in Firefox and Safari. And since I didn't want to implement, an elaborate server-side normalization system, I just kind of let it do the conflict resolution there. But as you can see, you can type back and forth between them. The problem, of course, is what happens if I close these guys. The servlet in this case that I'm running has a record of the full state of the application itself. And so if I just reconnect one of the browsers to it, they re-exchange their data, and away we go. Now the reason why I'm going to all this trouble to show you this is because I want to sort of point out that this is one way that you can build an application that synchronizes data between two browsers. And just to go through it real quickly here, this particular implementation uses a model view controller kind of thing. And so we have this class here, which is the controller. And as you can see, it's got a start main loop, and it just runs a timer loop right here. Runs about every, about 100 times a second. Doesn't necessarily always do something if it's already in the middle of doing something. But the real key is this method here, update. And as you can see, it's got a few intriguing methods in it, such as this sync from gears application. So if I set a breakpoint here, and then reload the page, it jumps into the debugger. And essentially the thing that I just want to point out is it skips right over that. The reason is that since this is WebKit, and unfortunately at this time we don't have a build for WebKit, this is an example of a browser connecting to a Gears-enabled application that where the browser itself does not have Gears installed. And so this is an example of how when you're in this new world order of building offline applications, you have to be aware of the fact that you can't just assume on your server side or even your browser code that you have the offline capability. And so I have checks in here, and if you were to look through my code, you'd see that I have checks like that essentially in all the key places. Sync to server in this scenario is a little more interesting, and this is what it does is it issues essentially an XML HTTP request call to the server to fetch the server state, which is asynchronous, and it explains the structure of this particular method. And then when I get a response back from the server, actually here, what it does is iterate over the array that it got back and essentially updates its local state in this code here to match the server state. And this block of code is also where the conflict detection and resolution happens via sort of poor man's optimistic concurrency and so on. So that's a basic summary of the application. And so far what we've seen is how you can have one application be accessible between two different browsers that are exchanging state. And that's great, but the problem is that if I shut down both of the browsers and shut down the server and restart the server, essentially all my state has gone into the bit bucket. It's now gone. So if I come back over here to Firefox and hit that URL again, I've got nothing. And so this is really where Gears comes in. So let me just get to my desktop here where, oh, lucky me, I just happen to have the XBI for Gears right here. So I'll just install this into Firefox real quickly. Wait for it to restart. at my URL again, and I get prompted, sure enough, for permission to access Gears. And this will look familiar. It is, of course, the same UI as we just saw a moment ago. And if I come back in here, you get the idea. Then what I can do is save this. And while I've just been speaking to you here, Gears has actually been busy in the background downloading the state for this application, or rather the application files for it. Well, either that or I didn't actually clear it from the last time I ran the demo. But the point here being that essentially I can now load this application offline. And if I restart the server, open up the hosted browser again, and re-access the URL, there's my data again. And so just to kind of make the point, if I quit this window here, shut down my server, then it does in fact load it out of the Gears managed resource store. So that's essentially how it works. And the final thing really that I want to go over now is I've shown you the application. You've seen that it's possible to build an application which has no knowledge of offline capabilities and instead just synchronizes data between two browsers. What I want to show you now is the bit of code that actually makes it possible for me to handle this offline. And so if we go back up here to this top level loop again, find the update method. I want to take a closer look at this method that we sort of skipped over before. In the case of Firefox, where Gears is installed, it actually skips over, or it does not skip over and return early here, and instead goes into this method. And you can see that structurally, this looks very similar to the RPC version that requests the data from the server. It's just that it's a little simpler because we sort of implicitly trust the database to give us its state. It's not asynchronous, and so it doesn't have as much code structure and trapping around it. And so given this thing, the real magic is what happens in this method here. And you can see that if you've ever done SQL programming before, then this will look pretty familiar, I'm sure. In particular, if you've ever done SQL programming in Java, you'll see that this also follows a very similar or very familiar paradigm there. I have this reference to a database handle. I execute a SQL statement and assign it into a result set, and then I just process the result set, which exposes an interface that is much like a Java iterator. So, the real interesting thing here is these queries. So let's check these out. Oops. And these, again, are going to be pretty familiar to anybody who's done SQL programming. I have the statement that creates the table if the application determines that the table does not already exist. I have a query that I run to determine if the table already exists. Statements to insert new records, update existing records, fetch existing record data, and so on. And then in the constructor for this class, and I should point out at this point that this particular class is an encapsulation of all the Gears-related logic, so that's why this is in a class by itself. It has all of the Gears-related code and just exposes methods that are useful to the controller. So in the constructor, we attempt to create the database object and then can access the local server, create a managed resource store, tell the managed resource store the location of the file that lists the contents of my application. In this particular case, I had all this pre-compiled so that I didn't have to stand up here and fool around with the manifest file for you guys. And then essentially just kicks it off and says, please go fetch the latest version of my application. And then down below, we have the usual methods for fetching the list of notes, which we looked at earlier, and then a method for updating an existing node in the database. And that really is more or less all there is to this particular demo app. And part of the goal of this application is not to introduce a lot of abstractions. The GWT API itself at this point, for Gears I mean, is still pretty new. And we are not at all sure that we understand what the use cases of our particular set of developers will be. And just sort of following the rule of 3 for good API design, we don't want to go off and try and design an API and some elaborate mechanism or something, and then completely miss the target and end up implementing something that our users can't use. And so we're going to follow, I think, sort of a process parallel to what the process that Dojo has sort of blazed the trail for. And we're going to see what our users want, find out how they want the library to work, and go from there. So just to sort of wrap up, you may be wondering what the actual GWT API looks like for Gears. And this is it. There's a few sort of top-level classes here, some browser-specific stuff where needed. And then the real magic happens in these 3 packages here, where there's one for the database, there's one for the local server, and there's one for the worker pool. Oops, wrong line. The database one we just saw, it's got a database object which represents a connection. It's got result sets for returning them. The local server has a managed resource store. And again, if you were to compare this API to the actual JavaScript level Gears API, you'd find that it's pretty similar. The one thing that I didn't demonstrate today, and this is a great example of what I was talking about just a moment ago, where we don't want to go off and try and implement APIs when we're not entirely sure how our users need to use them, is we don't really have, our worker pool API right now is quite simple. The reason is that the worker pool requires a JavaScript string. So you essentially construct a body of code that you pass into it, and then it then evaluates and executes that code. In the case of GWT, as you can see, we're actually compiling JavaScript or Java code to JavaScript. And so there's sort of an open question here as to what it means for us to start with a Java class, and how do we compile that? Are users going to want to use an anonymous inner class and compile that to a string that they pass in? Would users prefer to have their entire child worker code in a separate GWT module, which is compiled independently and maintained independently? These are answers that are specific to our framework, but that we don't have the answer for. And so those are the questions that we're interested in solving with the community. And so I said that I was not going to show you any more slides, but I lied, because I do want to show you this one last slide, which is really just a summary of the project status. This particular library for Gears is really the inaugural library in what we're kicking off to be a sort of collection of libraries for Google APIs for GWT. We thought it would be cool to start with Gears because it was timely and awesome, frankly. And so as time goes on, we'll be adding more and more libraries or more APIs to complement Gears in this library. We're open source, Apache 2.0 license, the same as GWT proper. And if this is something that you're interested in helping us out with, if you're a GWT user and find this exciting, then please, by all means, join us on our GWT forums and help us out with this. So that was it. That was all I had today. I hope you guys enjoyed it. I think looks like we've got a few minutes left to take some questions, and I'm sure that Brad would be happy to come up too if anybody has questions on his portion.
That's right. If folks can always go to the microphone for your questions so we can capture it on video.
Yes, hi. You may not like what I'm about to do, but my previous job was director of engineering for a company who had a hosted ASP solution for vacation rental managers. We are the new guys in the market, and for us, one security problem would have killed us. I'm looking at this and saying, what if somebody else gives them the widget or whatever first before we can? So if they get infected email, they could put down their own GWT or whatever, and then we would end up using that.
Who would you like to answer that?
Well, I also want to propose a solution. Because it's all open source, it's really easy to do something like this, although I think open source is great for security. Then I want to propose a solution of taking the open source, modifying it with some sort of key, and downloading it under a different name, Would that work?
So when you say downloading the source, are you referring to essentially perhaps digitally signing the body of JavaScript code that you are running in the browser, or are you referring to signing or somehow protecting the actual Gears runtime?
The Gears runtime is my biggest concern. And I know this is no less, than downloading a version of Microsoft Word or something like that. But my company has now lost a lot of security.
Mm-hmm.
So is there a way around that?
I want to make sure I understand your question. So is your concern that, is your concern with security related to the security of an application that you develop for Gears and push to it, or is your concern that your application, which is completely unrelated to Gears, and doesn't use Gears, is now made more vulnerable by an attacker who pushes Gears into a browser? Can you? I'm not quite sure I follow.
I'm sorry. No. What I'm saying is that if we take what's now is running our data center, we have it behind firewalls and databases that we own, and we spend a lot of money on networking and security, and now we have an offline version.
Mm-hmm.
And that offline version gets read by the Gears widget. And it only comes down once, right? You don't get it every time you visit a website. So if somebody maliciously sends out an email, here, click this, you'll probably need to install a plugin, and they put down the plugin, that now corrupts my application.
Do you mind if we take that offline and talk to it afterwards? Because I
Okay.
don't completely understand. I want to understand it.
Yep.
And maybe right afterwards, because I want to give everyone a chance to talk.
Sure.
But thanks.
Earlier in the Gears discussion, there was a mention that, or the Gears fireside, there was a mention that transactions have some overhead, and there was actually a suggestion that transaction and transaction commit should be done in a worker thread, generally, as opposed to in the UI thread. But in the code that Dan showed, I didn't see where the commit was happening, but it looked like it was in the UI thread. Have either of you seen any issues with that? Is that actually true, or is it not really that big a deal if you're not doing all that many?
This specific example is intentionally simple. You're absolutely right. I don't use transactions in this at all. It would benefit from having them, and doing that kind of work in a worker pool would probably be a good idea. My goal here was to show how one way that you might build an application, not necessarily the best way that you would build an application. So it's really, no pun intended to get the gears working, in your heads. Do you want to address the question for Dojo?
Yeah, so to be honest, I'm actually still learning the transactional method of SQLite under the covers and exploring what can and can't be called from a worker thread. I mean, I may be wrong, but I think my understanding is that a worker thread can't call the result set, the underlying APIs for the database right now. And so I don't think you could do that there. And yeah, I have actually more to learn as well about the transactional semantics of SQLite. But as far as I understand, there's a SQL statement to begin and to end a group of statements that are going to be transactional. Does that answer your question?
Yes, I think so. Thank you.
Okay.
I think, excuse me, I think with security, one of the things that helps is separation of concerns, having the server handle some of the security mechanism rather than the client. Now you're proposing downloading bunches of data onto the client systems. Client systems are traditionally less secure. I just would like to hear your comment on that. Kind of reflects back on what the guy was saying earlier. But also, I did notice this. You have an encryption and a decryption algorithm running on a workstation where you're entering the passphrase on the workstation.
Mm-hmm.
A lot of different ways somebody could capture a passphrase. Keylogger. Somebody could be hijacking JavaScript objects. Somebody could be modifying the DOM maybe, or grabbing some kind of password field. How do you see that as a challenge?
Well, I just wanted to say just one thing. We have time for just one more question after yours. Great question. I mean, security is really important. Just because you have that cryptography is not a silver bullet. It doesn't solve all your security issues. You have to think these things through. If you've got code on a web page that's from a foreign host, you could have mashup issues. where they can read your database. They could set up some kind of JavaScript keylogger. If you've intelligently put the boundary around your application, then the concern becomes compromising of the local machine itself by executable code. At that point, you have a lot more to worry about than a keylogger, because the way that OSs work now is it's sort of an all or nothing kind of thing. I mean, Windows Vista has some protection against that, Unix machines, Mac OS X, but when you're within the browser, you need to think through the security issues, and I think that's I think a future strong direction would be to provide some strong guideposts and warnings.
Yeah, because we're going from one centralized location with security to, multiple user locations.
Yeah. No, and it's a very real concern, and which is why the use case of a stolen laptop was one of the important use cases. But there could be some deeper things that are realistic in a threat model that need to be analyzed. Do you want to?
I actually would just simply second his, Brad's statement that security is extremely important, and it's the kind of thing that we spend a lot of time thinking about as well.
So this is the last question.
Yeah, but one question, whenever you have syncing and multiple data sets pushed out, is the concept of conflict resolution. And
Yes.
it's something that would be really helpful for like a Dojo or GWT to help developers with.
So that's a good question. I didn't get to go deep into Dojo Sync. Dojo Sync has some recommendations around conflicts. When you've got document A and document B, and they're the same, and you're syncing them, you could get conflicts. What we recommend is that if there's a conflict, that you automatically do the best case, we give your application a way to make a best decision about which one to choose or to make a copy of both. We recommend that you don't pop up a really complicated merge UI. Most developers want to put like a subversion merge or CVS kind of thing, like users care. And I think it's an open research question to create a usable merge UI. And so we recommend that you make a best case, and then in the Dojo offline UI, we provide a hook to inform the user if there was automatic merging. So we give a check mark, say succeeded, and then we say details. And you can click that to get a pop-up window that gives you a command log that may say automatic merge here, or conflict is detected, copy of old document made here. But I think users will probably like that more. There's probably some specialized cases where not, and again, we provide hooks where you could override and could do a merge UI for a specialized application, but I would recommend against it for usability reasons. Yeah? Thanks.